This conference will now be recorded. This conference will now be recorded.
Yes. Any idea what you mean by extraction? No idea?
No, ma'am.
Anybody? No idea at all? See, extraction is a process of taking out something. Okay, in common words, I have to tell you, taking out of active constraint, taking out of something in the sense here we are more concentrating on the active constraint, or in general what we call it as active ingredient. So that active ingredient could be any drug. Okay, in general there are various terms what we use for drug. So that is, you call it as API, that is active pharmaceutical ingredient. Remember the drug. So you know what is a drug, right? So a drug is a substance which is going to be used for any treatment or for diagnosis, for these purposes, right? So to treat a particular disease as well. So this drug can also be called by various other terms. Okay, like active ingredient. Active ingredient in the sense, out of so many things which are present in a dosage form, at least now you know what is a dosage form. At least by now you are aware of what is a dosage form, right? Dosage form is nothing but in which form are you delivering the drug. So whether it is in the solid, liquid, or semi-solid, it could be like this. Or in which form, in the sense, in which dosage form, in the sense, it could be anything, whether it's a tablet, capsule, or is it a syrup or linctus, anything. Okay, so these are known as dosage forms. Okay, so in general, in the dosage form, there would be other ingredients also present other than the drug. Okay, which is actually the requirement, the drug, not the other things. But why are we going to add other things? I think introduction chapter is over, so now you have to tell me. So if drug is the only intention of taking, or like the medicine or the drug only is the intended ones which we have to take, why are we going to take other ingredients which are not of use? Why is there a need of other things what we add into the dosage form? Anyone? Since introduction is over, you should be able to tell now. I'll
Ma'am,
repeat. Yeah. Yeah,
Additives
Aisha.
are added
Yeah,
to
why
protect
additives are added? I just wanted the
to,
word, the term from your mouth. So additives, why are you going to add additives?
to increase its stability and
Okay, to increase its stability. Good.
to give a proper form, like
Right.
proper shape and
Okay.
all. That's it.
Anything else? That's it.
No, no.
See, yeah, these are few of the things what you said. This additives are also known by some other words, other terms. Additives are also known as, they are also known as excipients. Okay, excipients. So the drug along with the additives are also known as excipients. Okay, so drug along with the additives or the excipients make up the dosage form. So why are we going to add this additives or excipients is that, as you said, for stability reasons. There are other reasons why we are going to add. For example, to increase the aesthetic appearance, how it looks, just to increase its look, right? Its appearance. So we add color to it. To increase the taste, we add sweetening agent. To increase the appearance as well as the flavor, we add some flavoring agents, right? So not only that, main intention of addition of excipient is that to increase the bulk, or what we call it as bulk, in the sense just to increase the weight. For example, if you consider any of the tablet as such, certain times the content of the drug is so small that if at all, if directly you have to take only the drug, it is very difficult to handle that particular drug. Handle in the sense, it could be powder, so very small quantity of the drug, certain times you can't even weigh it so much, so less quantity it is. In that case, it should be easy for us to take it. We have to handle it, we have to take it from hand, then it put it into our mouth, right? So it should be able to handle. So therefore what we do is that we increase the bulk or weight of the dosage form. For that reason also we are going to add this excipients. Okay, not only that, most of the drug would be bitter in nature. To increase the taste, we add the sweetening agent and all other ingredients wherever it's required based on the necessity. So we keep adding the excipients or the additives. Clear? So now extraction, when it comes to, I was talking about the active ingredient or active principle. There are other terms which we use for the drugs. So drug, medicine, active principle, active pharmaceutical ingredient, in short we call it as API, all are same. Okay, so what does it mean is that whatever other additives or the excipients we are going to use, they are not active. They'll be imparting their own properties. I agree that the sweetness or flavors, they do impart their property, but they do not have action on their own. In the sense, they do not show any therapeutic activity. I hope you know what is therapeutic activity. So they do not have any action towards the biological system. It's only the property what they impart is this flavoring, coloring, or whatever they are intended for. Other than that, they do not show any activity of their own. That is why they have been used. Okay, so the only activity shown is only by the drug. Clear? So when it comes to extraction, so extraction is a process of taking out or extracting, we say. So taking out of the active principle which would be present in a plant or animal tissue. Is it clear? So what is extraction? Extraction is a, so in this particular chapter, we are going to cover up these things. So the contents of this chapter would be definitions, what are involved in this, the solvents which are used for extraction, which are the different extraction processes. In that in depth we would be studying about a process known as maceration, another process known as percolation, and another process known as continuous hot extraction process. So these are a few of the extraction processes which we are going to study in detail. Other processes are there which you should know, so which comes under this extraction process. So moving on to the definitions, as I was talking about extraction. So extraction is nothing but treatment of plant or animal tissue with solvents. Okay. So wherein this solvents would act on the active constituents. So now you know what is an active constituent. So active constituent is nothing but the drug having some activity, therapeutic activity. Okay. So treatment of plant or animal tissue with solvents which will help in dissolving the active constituents that would be present in the animal or plant tissues. Okay, and whatever inert matter are there. What is inert? Inert in the sense which are of not use. Okay, so which inert matter are there, they remain undissolved in the solvent whatever we are going to use. I'll repeat. So what happens in case of extraction is that we are going to add a solvent. Okay, we are going to add a solvent to an plant or an animal tissue. Okay, we are going to add it to a plant or animal tissue. It could be anything, say it could be leaf, flower, anything. Okay, so we are just going to add a solvent to animal or plant tissue. And what are we going to do is that, what is our intention of addition of the solvent to this tissue is that whatever contents are present in this plant or animal tissue is there, so the content whatever main we require, say the active constituent or the drug which is present in the plant tissue, will dissolve in the solvent whatever we are going to add. Okay, so whatever active constituent or the drug is present in the plant or the animal tissue gets dissolved in the solvent whatever we are going to add. Whatever other things are there which are not required for us or which are not dissolved by this solvent, they will remain as it is. Is it clear? So our intention is to take up the active constituents from the animal or plant tissue. So extraction is nothing but we are extracting or we are taking up the active constituents or the drug of our intention into the solvent whatever we are going to add. Is it clear? Extraction. So the topic is extraction and galenicals. So what is galenicals in there? So galenicals actually comes from the term Galen. Galen is a scientist who found this. That's why the name galenicals. Okay. So in general, galenicals are nothing but the product obtained after the extraction. That is nothing but we are telling that active constituents will get dissolved in the solvents. So whatever active constituents are dissolved in the solvent, this particular product we are going to call it as galenicals. Okay, so galenicals are nothing but the products what we obtain from the process of extraction. Clear? So now there are other terms also which are commonly asked in exams. Remember, menstruum and mark. There is a term known as menstruum. So menstruum is nothing but a term which is used for the solvent which we are using for the process of extraction. Okay, menstruum is nothing but solvent used for the extraction is known as menstruum. So solvent could be anything. It could be water, alcohol, or any other organic solvents. Whatever solvent we are going to add it on to the plant or animal tissue for dissolving the active constant or for the extraction process, we are going to call it as menstruum. Okay, there is one more important term known as mark. So mark is nothing but the inert matter which remains undissolved, we are telling, after the extraction process, that we are going to call it as a mark. I'll give you an example by which you will understand this as well as extraction. Don't mind, I'm giving you a common example because most of you would know it. So again, I'm taking example of tea, preparation of tea, which is actually an extraction process. Okay, common extraction process. If you take tea, you would consider for preparation of tea. Anyone, what and all ingredients do you use for preparation of tea? Don't mind because all of you understand better, so I'm using this common example. Yes, anyone knows how to prepare a tea? What and all ingredients do
Tea,
you add?
tea leaves,
Tea
sugar,
leaves, sugar,
water,
water,
milk,
milk.
and that's it.
That's it, right? So these are common ingredients what we are going to use for preparation of tea. So if anybody tells me what is the exact process how you carry out, later I'll tell you what is what. How do you exactly do preparation of tea? How do you prepare tea exactly? Anyone? Nobody knows? Who told me the ingredients? They would know how to prepare tea as well. Nobody knows to prepare tea? No or yes?
Yes, ma'am, we know.
Yeah, tell me. That's okay,
No,
even
ma'am,
if
we
you go
don't
here
know.
and there. Okay, at least those who know can answer. Aisha, tell me.
Ma'am, we boil the tea leaves in water,
Yes,
add a little bit of sugar, and then add milk.
right. Okay, whatever you are telling, I'll tell it in the terms whatever we have used here. So now our intention is to extract the tea content from the tea leaves. Is it clear? I'm giving an example. Don't write it in exam. Okay, just for your understanding, I'm giving this example. Again and again, I'm telling, please do not write this example in the exam. So our intention right now is extracting the tea content from the tea leaves. Okay, so tea content, when you say tea leaves, is nothing but the plant tissue, right? What solvent are we going to use? It's the water, boiling water we are going to use so as to extract the tea content from the tea leaves. Tea leaves is nothing but the plant tissue. So this is nothing but the extraction process. Clear? Is it clear? Extraction. So now,
Yes.
whatever tea decoction, we call it as decoction, right? So whatever tea decoction we get when we use boiling water, we add tea leaves and we just boil it without adding sugar, just assume. Or if after addition of sugar also, that particular tea decoction is nothing but the galenicals, or that is nothing but the product which we are interested in. Okay, the product obtained after extraction or the tea decoction is nothing but the galanical, or if you can add sugar as well as milk, what we call it as tea, that itself is a galanical. That way also you can say. Okay, so now for the preparation of the tea, what solvent did you use? For the preparation of tea decoction, what solvent did you use? Water, boiling water, right? So boiling water now becomes the menstruum. Clear? Boiling water is the menstruum or the solvent which we are using for extraction. So then what is mark? Mark is nothing but after boiling the tea leaves, we are going to take out the tea decoction by filtering, right? So whatever remains on the filter, that is the tea leaves, which we do not want. We just want the decoction or the extract, right? Whatever is remaining, the tea leaves, is nothing but the mark, which is inert, insoluble. It is not soluble. The only contents which were present in the tea leaves, they come into the boiling water. All other contents, the tea powder, whatever we are taking, or the tea leaves, whatever we are taking, these are the inert, insoluble matter which will remain after the extraction process. Is it clear? What is extraction? What is galenical? What is menstruum? What is mark?
Yes, ma'am.
Okay, we'll go further. So moving on to next, solvents for extraction. So that was an example of a common example. But in pharmacy, whenever we are intending to prepare some decoction, there are different products known as tinctures. You would have heard these terms: tinctures, decoction, concentrates. There are different terms like this what we use. Okay. So these terms, whatever we are using, are nothing but the products or the galenicals, what we are interested in. Fine. So for preparation of the same, what and all solvents are we going to use are nothing but the solvent for extraction. Okay. So solvents employed, they should be able to penetrate through the tissues. What do you mean by penetrate? Penetration. What do you mean by penetration?
I'm getting through it.
Yeah, getting through it, getting through the tissues. Okay, we are talking about getting through the tissues here. So whatever solvent we are thinking of taking for our extraction process, any extraction process, because you do not know any extraction process, you can keep the same tea preparation only in your mind. What solvent are we going to take for the extraction process? It should be such that this should be able to pass through the tissue whatever we are taking. Okay, tissue of the drug. And main and important thing is that it should not only pass through the tissue, but it should be able to dissolve the active principles which is present in the tissues. Is it clear? Solvent whatever we are taking for extraction should be such that they should be able to penetrate, or they should be able to pass through the tissues of the plant whatever we are thinking of, as well as they should be able to dissolve the active principles which would be present in these tissues as well. Okay, for example, the previous example only, if I take the tea, we are taking water and we are boiling the water so that there is effective extraction of the tea content from the tea leaves. Yes or no? Just imagine, instead of water, boiling water, okay, instead of boiling water, if I take water, what happens? There is extraction. Okay, there is extraction that would takes place, but not much. As in case of boiling water, it is not much. If I have to give you an example, if you take a normal water and you try to dip this tea bags, what you get? So extraction is not that great as in case whenever we use a boiling water and then we try to boil the whole content, right? So content or the extraction process is efficient when we are using boiling water rather than a normal water, right? So similarly, our intention of taking any solvent should be such that they should be able to pass through the tissues, as well as they should be able to dissolve the contents what we are intending to take. Okay, so based on this, there are various solvents which we are using for the process of extraction. So they are water, alcohol, and other solvents. Okay, so we'll study one by one. So moving on to first solvent, which is water, so which is commonly available, right? So it's a solvent for protein, for dissolving protein, coloring matter, gums, glycosides. All these are the plant content, okay? Plant tissue or plant matters. Gums, glycosides, sugars, alkaloidal salt, and most organic salts. Okay, because water dissolves all these matters. Whenever we are thinking of taking up any protein from the plant, thinking that this is our active ingredient, so in that case we are going to use water because protein gets dissolved in water. And most of the waxes, fats, fixed oils, and most alkaloids are insoluble in water. So we cannot use water for these contents whenever we are thinking of, or whenever our active ingredient is some wax or a fat or a fixed oil or an alkaloid, we do not go for using water as a solvent for extraction. We go for other solvents. So other than these, most of them, these, whenever we are intending to take it for our extraction process, we are going for water because these content will get dissolved in water. Okay, so water will penetrate through the plant tissue for dissolving these contents. Okay, so that is why we are going for, as well as these will get dissolved in water. So what are the advantages of using water as a solvent for extraction? So first and foremost is it is easily available, right? Water is easily available than any other solvents. So it is easily available. It is cheaper. Water is the cheaper solvent what we can expect. And it has wide solvent action. Wide solvent action in the sense it will be able to dissolve most of the contents whatever are there. That is why it is known as universal solvent, right? Water is known as universal solvent because most of the content would get dissolved in it. Therefore, it has wide solvent action. It is non-toxic. What do you mean by non-toxic? What do you mean by non-toxic? Anyone? What do you mean by non-toxic?
It's not poisonous.
Yes. So it's not poisonous nor it cause any harmful effect to anyone. So it's non-toxic, right? And it's non-inflammable. What do you mean by non-inflammable?
It cannot catch fire.
Right. So it will not catch fire. See, most of the solvent, especially these organic solvents, while using these organic solvents, we should be very careful because they catch fire. That's the most this thing. And as well, on most of the organic solvents in chemistry labs, when you come for doing the experiments and all, you can observe on the bottles of these organic solvents, it would be written very well. Not it is toxic, inflammable. It would be written very clearly, flammable as well as toxic. So you should be very careful while handling the organic solvents. So it's not like that. So water is non-toxic and non-inflammable. So what are the disadvantages for water if we use it as an or extraction solvent or menstruum? If you're using water as a menstruum, what are the disadvantages? See, being a universal solvent, it will be able to dissolve most of the constituent, right? It's an advantage we said because it will be able to dissolve most of the content. But we have disadvantage with this particular property of water is that whatever constituent we do not want, even there are chances of dissolving even that into the menstruum. Okay, water being the universal solvent, it will be able to dissolve most of the content. Therefore, other than the drug or the active principle what we are intending to take, along with that there are chances of other constituents also coming along with the active constituent. Is it clear? Because it will be able to dissolve most of the content, whatever is our intention, the active principle, along with that other constituents also dissolves in water. Therefore, we get mixture of constituent, that is active principle what we want as well as other things also. There is a disadvantage with water as a menstruum. Not only that, since water it's a good source for growth of microorganism, it promotes growth of microorganisms. So wherever water or moisture is there, you expect more growth of microorganisms, or contamination from microorganism is highest whenever you use water as a medium or the menstruum. So then, say now whatever extract we are thinking of is an aqueous extract. Aqueous extract in the sense we are using water as a solvent. We call such extract or a product as aqueous extract. Okay, so this aqueous extract, if I have to get a concentrated product, concentrated aqueous, when you say there is more water, when I'm telling concentrated, there is quite less water in that. So if I have to convert this aqueous product into a concentrated product, I either subject this particular product for a process known as evaporation. Okay, so evaporation, whenever we are subjecting, we are going to heat the product. Okay, if we are heating the aqueous product, what happens? Continuous heating leads to concentration. Okay, so if at all, if we are using water as a menstruum, we require more amount of heat for getting a concentrated product. Okay, if our intention is to get a concentrated product from an aqueous product, so the aqueous product has to be heated so as to get the concentrated product. So if we are using water as a menstruum, so what happens is that you require more amount of heat for getting a concentrated product. So these are water as a solvent or a menstruum, and what are its advantages and disadvantages. Any doubt in this? Understood?
Yes, ma'am.
Okay, moving to next. Next is alcohol. Okay, so most of you would know what is an alcohol and all. There are different types of alcohol. Amongst this, most commonly used alcohol for extraction is methyl alcohol and ethyl alcohol. Okay, so out of these methyl alcohol and ethyl alcohol, methyl alcohol is quite harmful than ethyl alcohol. Okay, the methyl alcohol can it's toxic than ethyl alcohol. So in general, when we say alcohol, it is ethyl alcohol. So methyl alcohol is toxic to human bodies. So in general, alcohol, here we are talking about ethyl alcohol, or we can use even methyl alcohol, because even that has a very good extracting property. But here we are concentrating on the ethyl alcohol. So this alcohol is a solvent for dissolving alkaloids, alkaloidal salts, glycosides. See, what are these terms? In pharmacognosy, you're going to study what are alkaloids, glycosides, all this. For now, time being, remember that these are the active principles which are obtained from the plants. Okay, so these are the active principles which we are going to obtain or take it from the plants. So these are the different terms what we are going to use. For now, remember this. Okay, so volatile oil, at least you would know what's a volatile oil. What's a volatile oil? Nobody knows what is a volatile oil. If no,
That
I'll explain.
evaporates easily.
Yes, that evaporates easily. Example, which oil evaporates easily? These oils what we are going to use for this perfumeries, the perfumes what you use, the fragrances whatever they add, these are nothing but the volatile oil. Like it could be flower extracts like lavender oil, rose oil, jasmine oil, or it could be others like this clove oil, eucalyptus oil. Eucalyptus oil is commonly used household, right? Whenever there's cold or anything, you add this, right? Eucalyptus oil, all these are volatile oil. Volatile oil in the sense they have oil content. The problem with this is that they volatilize, that is when you keep it open in the air, they evaporate. So there is more tendency for these content to get evaporated whenever it's been exposed to the atmosphere. So these are volatile oil, that is why you have to keep it closed always. Okay, so these are few of the example of volatile oil. So these alcohol will be able to dissolve volatile oils. Resin, what is a resin? What's a resin? No idea. No idea what's a resin.
No, ma'am.
if you go towards wherever there is more of trees, certain places, you observe that there would be cut made on the sides of the woods, and they would just tie something so that a liquid starts exudating or coming out from those um, whatever they are going to cut off, no, from that particular portion, liquid starts pouring off or oozing out from that particular cut. So that liquid is nothing but the resin. Okay, so few of the trees, not all the trees, so few of the trees, when cut open, when they make a incision or a cut, they start releasing a liquid. So a liquid starts oozing out from the cut, whatever is being made. Okay, so that cut, that exudate, or what we call it as the liquid which comes out or oozes out from the cut, it slowly starts becoming hard. Okay, when exposed to the atmospheric air, they slowly start becoming hard. So that that particular liquid is known as resin. So it's no more a liquid, it becomes semi liquid or solid certain times. This you would have observed even in a common tree, certain brown coloration you observe, a liquid which starts coming out from the tree, which hardens on exposure to atmosphere. That's nothing but the resin. So all these content are they are dissolved by the alcohol. So they dissolve many forms of coloring matter, tannins. Again, tannin is a kind of uh, active principle which is obtained from the plant source, many organic acid and salts. So alcohol will be able to dissolve all these contents. So it does not dissolve certain contents like albuminous matter, gums, waxes, fats, fixed oils, and sugar. Okay, so certain times we go for water for sugar, fixed oils and fats we go for any other solvents. Okay, so alcohol will be able to dissolve all these contents, so we can go for extraction whenever we are intending of these particular active principle. We can go for alcohol as a menstruum. Okay, so what are the advantages of utilizing alcohol as a menstruum is that because alcohol itself has an antibacterial activity. Okay, it will prevent growth of microorganism. So hence mold and bacteria cannot grow up to a concentration of 20% of more or alcohol. If we are using alcohol in a strength of 20% or more than 20% of alcohol, what happens is that alcohol itself will be able to prevent the growth of bacteria and mold, unless like water was promoting growth of bacteria and mold. Because alcohol itself has an antibacterial property, alcohol will be able to prevent the growth of mold as well as bacteria. Okay, then this particular alcohol being neutral, that is, it does not react with any of the content, therefore this alcohol can be is compatible. That is, whenever we are going to uh, use this alcohol for the extraction process, the products which we are going to obtain from that, they are compatible with the other products. What do you mean by compatible? What do you mean by neutral? Neutral in the sense they do not react. Okay, they do not react with anything. What do you mean by compatible? It's the same. Compatible means there is no reaction, or compatibility. The term we use, compatibility, that means it is okay. So there is no problem on using alcohol with other contents because it does not react with those. Okay, so being neutral alcohol, so whatever preparations we are going to prepare using the alcohol as a solvent, the product will be compatible with the other things. And alcohol is again non-toxic. Again, I'm telling, ethyl alcohol is non-toxic, but methyl alcohol is toxic in nature. Okay, a small amount of heat is required for concentration. Say now we have an not aqueous extract. Aqueous extract, when you say, always remember aqueous term itself is used for water. Okay, so here if we have dilute solution, I hope you know what is the difference between dilute and concentrated, right? Dilute is nothing but the solute or the salt, whatever salt, not exactly salt, the solute whatever we are thinking of is in lesser concentration than the solvent. Okay, this is known as dilute solution. Solvent is more, solute is less. Okay, and concentrated product is the one where the solute is more and solvent is less. Okay, so what's a solute, what's a solvent? Solute is usually a solid which will get dissolved in a solvent. And what's a solvent? Solvent is a liquid usually which will be able to dissolve the solid. For example, you can tell water and sugar, water and salt. Water is a solvent and sugar or salt are nothing but the solute. Okay, so if we have an dilute solution, okay, that is extract. If we have a dilute extract and we are intending to have a concentrated extract, okay, wherein in case of aqueous extract or a dilute extract of water, we have to supply heat for concentrating it, right? But in case of alcohol, because alcohol itself is volatile in nature, right? Alcohol, if you keep it open for a longer time, it starts volatilizing or it starts evaporating into the atmosphere, right? That is why we keep even alcohol closed. So in general, whatever concentrated product we are intending to prepare, there is no much heat in case of alcoholic extract if we want a concentrated product, unless like water heat is required to a greater extent. Alcohol itself is volatile in nature, so it requires very less amount of heat for getting the concentrated product. Okay, so another important advantage of alcohol is like it will be able to dissolve only the selective constituent, unless like water being a universal solvent, on a whole it will be able to dissolve most of the content. But alcohol, it is selective in nature, only few constituent or only the constituent which we are thinking of would be present in this particular tissue, only those content will get dissolved in the alcohol as such. So it is much more selective when compared to water as a solvent. Moving to disadvantage, most important disadvantage with alcohol is it is costlier. It is most usual. Not only that, because solvent itself is costlier, the preparations what we prepare from the by using alcohol will also be costlier. Okay, so cost, it is not cost effective for using alcohol as a solvent. But if we are thinking of better extraction as well as only contents which would dissolve only in the alcohol, yes, we have to go for it, but it will be costlier process, as well as the product what we obtain from that will also be costlier. So other than water as well as alcohol as a solvent, we can use other solvents for the extraction process. So what and all solvents can we use? Most of the organic solvents, solvent ether, chloroform, light petroleum, certain acids are rarely used for the extraction process, even methyl alcohol. So ether, um, most of the organic solvents we can, carbon tetrachloride certain times, but we cannot use it for oral purpose and all the whatever product we are getting from this. So all these solvents can also be used wherever we cannot go for water or alcohol as a solvent. Or say now there are some problems on using water or alcohol, we can go for these solvents as menstruum instead of water or alcohol. Is it clear? This is about menstruum, that is alcohol, water and other solvents. Are there any doubt till here? Understood?
Yes, ma'am.
Doubt?
Yes,
Yes,
ma'am.
ma'am.
Understood? Okay, we'll go next. So moving to different extraction process. So till now whatever we studied was what are the solvents, what can we use for the process of extraction, right? Moving to next, what are the different extraction process that are there for getting the product or getting the galenical product. Okay, so what's a galenical? So galenicals are nothing but the preparations what we get after extraction. Okay, so what are the extraction process we are going to use for getting the product? So these are the processes. So various processes which we are going to use for extraction are infusion, decoction, maceration, percolation and digestion. Out of these, the first four are most commonly used. digestion is quite less used. Okay, so most common methods or process of extraction are infusion, decoction, maceration, percolation, digestion. Okay, so we are going to study all this in depth. Amongst all these five, we are going to concentrate more on maceration and percolation, because all others are used to a lesser extent, or the extraction, what we say, the extent of extraction is better when we go for maceration and percolation than any other process. So that is why we would be concentrating more on maceration and percolation process than other process. But you should know what are the other process. So we would be learning about all these processes. Is it clear? So I think we can start this in the next class, the different process. Okay, any doubt? Anybody has any doubt?
No, ma'am.
No, ma'am.
No, ma'am. No, ma'am.
No, ma'am.
Before that,